Now let's look at factoring sums and differences of cubes. Now, we have already looked at factoring trinomials by looking at greatest common factor or using the FOIL method, guess and check, or AC method or box method. And we've also looked at factoring perfect square trinomials and difference of squares. So now we're ready for sums and differences of cubes. So you're going to want to look at your formula sheet because these actually follow a pattern that is very easy to use if you understand the pattern. Before we get started, let's identify first what is a difference of cubes, difference of squares, sum of cubes. So number one says difference of cubes. So when you look at your options of A, B, and C off to the right, a difference of cubes, difference means subtraction, and cubes means everything's being cubed. So looks like option B is going to be our difference of cubes. Difference of squares. Now those are perfect squares. So what's perfect squares? Well, first of all, the difference, so we know it's subtraction, and both terms are perfect squares. So that's going to be option A. And finally, sum of cubes. Sum means to add, and cubes means perfect cubes. So sum of cubes. So it looks like that would match up with C. So let's actually look at some examples of sum and difference of cubes. So before we even get started with looking at samples, though, let's just go ahead and look at the patterns. Again, I'm going to get this same information from your formula. So for your sum of cubes, okay, sum of cubes. So that would be if we had something cubed plus something else cubed. How does that break down factoring? Well, the way it breaks down is what's being cubed in your first term, which would be A, plus what's being cubed in your second term, which would be B, and then it's followed by a trinomial. And we take what's being cubed in our first term and square it, so square A squared. Then we multiply what's being cubed in the first term and the second term, and we subtract that, and then we add the square of what's being cubed in the second term, so B squared. Now, let's look at what happens if we have difference of cubes. And the pattern is just slightly different. So difference of cubes means we have A cubed minus B cubed. So the way the pattern goes there is we have A minus B, and then we have A squared plus AB plus B squared. So you can see the patterns are very, very similar. They're only off by 2 signs. So we're going to come back to these and we're going to use these whenever we see a sum of cubes or a difference of cubes. So let's go back to some of our examples here. X cubed plus 125. Well, since it's a sum, we're going to use our sum of cubes pattern. And our sum of cubes pattern says we're going to have a binomial and a trinomial. Now, I always find it helpful to identify what is my A, or what's being cubed in my first term. Well, x cubed, what's being cubed? Well, x is being cubed. And what's being cubed in my second term? Well, 125 is 5 times 5 times 5. And since it's a sum, here is actually my binomial to help me get started, followed by my trinomial. So what goes in my first, or what's my first term of my trinomial? Well, it's what's being cubed in my first term. Since that's x, then I have x squared. Then I have a minus. Then I multiply what's being cubed in each of my terms. So I have an x times 5, and that would be 5x. And then what's being cubed in my second term? Well, that's 5, and so then I actually have to square that, which is 5 squared, which is 25. So what we've really done is our A in our problem ended up being x, and our b ended up being 5. So when I look at that pattern of a plus b times a squared, then this would be a squared minus a times b plus b squared. So what I literally did was I took what a was, which would be my x, and every place in my pattern that I see an a, I replace with an x. And every place in my pattern that I see a b, I replace it with 5. So this is actually my final answer. X plus 5 times x squared minus 5x plus 25. So let's look at the second example here, 64t cubed minus 1. So let's identify what our a and our b are. So a is what's being cubed in my first term. So what's being cubed to get 64t cubed? Well, that's going to be 4t. And what's being cubed in my second term? Well, that's easy because it's 1. So that's going to give me 4t minus 1 is my binomial. My trinomial is to take a and square it. So since it's 4t, that would be 16t squared. Then we're going to have plus, I take my a times my b, so that's 4t times 1, so 4t. And then my last term is always b squared, so b is 1, so 1 squared is 1. Again, final answer. As long as you have your formula sheet and know the patterns and know how to use the pattern, these are pretty simple to do. There's no work, you just have to apply the pattern. So let's look at this one. So, and you can rewrite this if you like. I'll probably just leave it in the same form. What's being cubed in my first term to get 8? Well, that's going to be 2. What's being cubed in my second term? Well, to get 27, that's going to be 3. To get y cubed, that's y. So 2 and 3y are my terms. So I've got 2 plus 3y is my binomial. My trinomial would be a squared, so that's 2 squared, so that's 4. And then it's minus a times b, which would be 2 times 3y, which is 6y, plus b squared, which is 3y. 3y squared would be 9y squared. So again, not too bad if you are aware of the pattern and you know how to use the pattern. You simply just plug in your a and your b into the pattern to get your factored form.